guys, welcome back to the channel. Today we are going to build a math quiz game using system Verilog. I'm going to break it down step by step so that by the end of this video you will know exactly how it all works. First, let me give you an overview of what this game does. Essentially, it generates random math problems. These can be either addition, subtraction or multiplication, and the player has to input the correct answer. Player's response, the game checks if the answer is right or wrong and updates the score accordingly. Now let's start with the design code. In the module Math Quiz game, we have several inputs and outputs. First, let's see the inputs. First, CLK. This is our clock signal which drives the sequential operation in our game. Next, we have reset underscore n. This is our reset signal and it's active low, meaning when it's 0, the game is resets. Next, we have player underscore answer. This input comes from the player. They enter their answer to the current math problem. Next, we have submit. This is the player's submit button which they press when they want to submit their answer. Now, let's see the outputs, number 1 and number 2. These are the two random numbers generated for the math problem. Next we have operation. This output determines which mathematical operation will be applied, whether it's addition, subtraction or multiplication. Next we have correct. This is a flag that goes high when the player submits the correct answer. Next we have score. This output keeps track of the player's current score. Alright, now take a look at the core functionality inside the game. In Verilog, most of the logic is inside an always underscore FF block which runs on the rising edge of the clock or when the reset signal is active. We use $symbol U random underscore range to generate two random numbers between 0 and 15 for number 1 and number 2. We also use a random operation generator. It randomly picks between three operations: addition, subtraction and multiplication. When the player presses the submit button, the code moves forward to calculate the correct answer. We use a temporary register temp underscore answer to store the result. Based on the operation, if it's addition, the answer is number 1 plus number 2. If it's subtraction, the answer is number 1 minus number 2. If it's multiplication, the answer is number 1 asterisk number 2. After calculating the correct answer, we compare it to player underscore answer. If they match, the correct flag is set high and the player's score increments by 1. If they don't match, the correct signal remains low and the score doesn't change. After processing one question, the system automatically generates new random numbers and a new operation, ready for the next question. This keeps the game going round by round. Now let's move on to the test bench. The test bench is crucial for simulating how the game will behave without actually playing it manually. We start by generating a clock signal that toggles every 5 time units. This drives the game's functionality. The RST underscore n signal is initially set to low to reset the game and then goes high after 10 time units to start the game. The test bench waits for the game to generate random numbers and an operation. Once the problem is generated, the test bench calculates the expected result based on the operation and automatically assign this to player underscore answer. Then it sets the submit signal high to simulate the player submitting their answer. After the player's answer is submitted, the test bench checks the correct flag. If the answer was correct, the correct signal goes high and the score increments. The test bench continues this process for multiple rounds to simulate ongoing gameplay. Finally, let's look at the waveform output. In the waveform, you will see CLK, our clock signal which drives everything. Number 1 and number 2, the random numbers generated for each math question. Operation, the math operation, whether it's addition, subtraction or multiplication. Player underscore answer, the input from the player. Correct underscore answer, the answer the system expects based on the operation and the numbers. Correct, a flag that shows whether the player's answer was correct. Whenever the player submits the correct answer, you will see the correct signal go high and the score increment in the waveform.
confirming that the game is working correctly. Thank you for watching.